So today we are going to be talking about proportions in triangles, so please fill in the blanks as we go along. So we're going to start with our side splitter theorem, and that says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. I'll give everybody a moment to write that down. As you're writing that down, we're going to talk about what this actually means. So we have line RS that isn't a part of triangle QXY, but it definitely is parallel to segment XY, as we can see by those little arrows, made those a little bit bigger. But with this theorem, so since that segment that is parallel to XY intersects segments QX on the left side and QY on the right, we know that the new segments that are created are going to be proportional. So if we were to start, say, at Q right at the top and then bounce down to R, and then from R to X, those are going to be our two segments, which is then highlighted over here to the right. So we have QR over RX, and then same thing on, and then same thing on the right side of the triangle. We go from Q to S, and then from S to Y, same thing that is highlighted over here. So if we knew those values, which we don't in this case, but if we plug those in, we'd get a proportion that we know is good. I'm missing a letter here. All right, let's go on to the corollary to the side splitter theorem. So that says that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So this is going to be very similar to the side splitter theorem, a little bit easier to work with though, in my opinion. So I made those arrows just a little bit bigger. Same thing. So we have parallel lines A, B, and C. Those run left to right in the image. And then we have lines A, C, and W, Y. Those are going to be our transversals that are cutting through the parallel lines. So just like in the first one, we're going to jump from A to B and then from B to C. So now we have these two segments here, AB and then BC. And then we can do the same thing on the right side from W to X and then X to Y. And then, so we know these new segments are going to be proportional. So we have A over B, AB over BC, and that is equivalent to, let's get a new color, we'll say blue. So we've got WX there and then XY, so we know WX over XY is going to be proportional to AB over BC. Okay, so now we have the triangle angle bisector theorem, bit of a tongue twister. So if we have a ray that bisects an angle of a triangle, then it divides the opposite side into two parts that are proportional to the other two sides of the triangle. So real quick, let's talk about what's happening to this angle. So if we have a ray that is bisecting the angle in this image, that will be angle A. So if an angle is bisected, that means it is cut into two equal smaller angles. So now angle CAD is congruent to DAB. So what this theorem is saying though, so we have ray AD that intersects segment CB, then the two new segments CD and DB are going to be congruent to the other sides of the triangle. So let's get a highlighter so we can actually see what that means. So if we start at the top, at angle A where it's being bisected, we're pretty much going to take a path around to the bottom of the triangle where ray AD cuts the opposite side. So we were at A, we have segment AC, and then we'll keep going. So we put that there, and then we have segment CD. We wrote that there. Same thing on the right side. We went around from A, turned the corner at angle B, and then headed to where ray AD intersects that segment. So let's get a new color. Same thing. So we've got segment AB, which we wrote there, and then BD. This one can be a little tricky for some people. Just remember, always start at that angle that's being bisected and wrap your way around to where that ray cuts through the bottom of the opposite side. Okay, so I know the answers to this set of problems is on here. We're going to go through one or two together, and then I want you to pause the video and try and solve the rest on your own. I will let you know when to do so, though. But let's start together. So for these problems, we're always going to start with the information that we know. So we've got AC, which is going to be right here. Ooh, let's get a highlighter for this. So we've got segment AC, and then that is over AI. So we've already got this almost V shape that is pointing to the right, and then we also are going to have CD somewhere in there. CD is going to be right here. So this is an example of the side splitter theorem because we are going to form a triangle with the sides. Our parallel lines in this case is going to be this line here. There is another parallel line, but that's not really creating a segment as seen by AC. So we've got our parallel line here, and then this looks like to be the bottom of our triangle. So then we need to figure out what the other proportional segment is. So in this case, we're going to have IJ or JI, either way you write it is correct. That is going to be the corresponding segment created by these sets of parallel lines. All right, let's do another one. So we have, again, we're going to start with what we know. So we know AB over BC. So again, this looks like it's going to be the side splitter theorem since angle A is coming to a point. And then we're going to have HI also highlighted. So this is definitely going to be another example of the side splitter theorem. We have our two sets of parallel lines right here and right here. So this larger line, or the longer line, is going to be the third side of our triangle, and then this is going to be the parallel line that creates the new segments. So this one, the missing segment is going to be AH or HA. Again, you can write it either way. So at this time, please pause the video, try and solve the last four for yourself, and then come back. All right, let's keep going through these. So we've got, for number 3, we've got BC and HI already highlighted. And then we also know that IJ is going to be involved. So in this example, since there's no triangle being formed, this is going to be the corollary to the side splitter theorem. We have our first, second, and third parallel lines as described in the theorem. And then this segment CD is going to be that other corresponding part that is created by those parallel lines. All right, on to number 4. So we've got GD over AD. So we've got GD and then AD. Okay, so this one's going to be an example of the triangle angle bisector theorem. And we know that because the segments that are proportional, they turn at the bottom of that angle. So then we're gonna, lost my drawing area. And then we also have segment JG. So if you look at angle A, we have two little marks there that say this is being bisected. So we're going to take a path from the angle that is being bisected all the way to the bottom of the ray that is doing the bisecting. So that's going to be AG in this case. So we go around AD down to DG. And then same thing on the other side. We're going to go from angle A around to point G. So we already have JG. That means to get there, we're going to need AJ. And that's going to be on the bottom to match the corresponding sides in that proportion. All right, 2 more. So we've got FG and EF. So we already know FG, and then EF is right above it. And then we also know that CD is going to be involved, which is going to be right here. So this is, again, another example of the corollary to the side splitter theorem. We're going to have 1, 2, and 3 sets of parallel lines. So we've got the first segment, EF, created by these parallel lines, and then the second segment, FG, created by these two parallel lines. So we're just going to be left with BC since we already know CD. And again, BC can be written as CB, either way, completely okay. All right, and the last one, we have AC over AI. So let's highlight those AC and AI. So this looks like we're back to the side splitter theorem. But let's just make sure the other proportion is going to have IJ in it. Yes, so we're definitely going to be working with the side splitter. So these segments are cut there with that parallel line, and then this is going to be the base of the triangle. So that only leaves us with CD. That is the segment on this line that is created by those parallel lines. And if you have any question about any of those, please just stop by a help session. We're more than happy to talk them out with you. Okay, so on to number 7. So this, since we have clearly a triangle with 2 sets of parallel lines, we know we're going to be using the side splitter theorem. So this can be written multiple different ways. This is just one example, but if we start at this angle and go towards the parallel lines, we'll start with 4x plus 1. So we'll put that in the top on this side, and then we hit x plus 4, so that's on the bottom. And then the other side of the equation, we have 20 if we're coming down this line, and then we see 8. So we put 20 over 8. So we're going to cross multiply. So we're going to get 8 times 4x plus 1 equals 20 times x plus 4. So just make sure you distribute, but 8 times 4x is going to be 32x plus 8. And then on the other side, 20x, and then 20 times 4 is 80. We're going to subtract 20x from both sides. You could subtract 32x, but it's going to give you a negative variable, so it's a little bit easier to work with. If you take away the 20, we are left with 12x, and then same thing, we're going to remove 8 from both sides, so we get 12x equals 72. Rewrote that up here just to give myself more space. Divide both sides by 12, we are left with x equals 6. And you're of course more than welcome to plug that x equals 6 back into our original proportion to check your work. All right, going on to number 8. So this is going to be an example of the triangle angle bisector theorem. So we'll call this angle A up here. That's the angle that's being bisected by this ray. So we'll extend that, make it a ray. And we're going to start there, wrap our way on that trip down to the bottom of the ray on both sides. So if we start at A, we're coming down this left side, we run into 20 first, that segment. We come around the corner, and then we see 16. So we put 20 over 16. Same thing on this side. If first thing we see is 4, come around that corner, we get x. So we write 4 over x. Same thing as last time, we're going to cross multiply. So we get 20x equals 4 times 16. 4 times 16 is going to be 64. And that's going to be equivalent to 20x. Divide by 20, divide by 20. X is going to give us 3.2. All right, number 9. So this one is a little bit trickier because if you notice, this whole bottom segment here is going to be 18, and this segment is x. So we're using triangle angle bisector theorem, but we need to know what this segment is. We don't know what x is. We know that it's x, but in this case, we're going to take the whole segment here, remove the part we already know, and we'll have whatever's left. So in this case, that's going to be written as 18 minus x. Of course, we don't know exactly what x is, but this problem is going to tell us what that is. So eventually, we will be able to figure out what that side length is. And if you think about it, if we call this segment 18 minus x, and we add the x segment to it, we are left with 18 because these are going to these x's are going to cancel out, and 18 is the original length, so we know we're on the right track. So, same thing, we're going to follow around to the bottom of the ray. So we run it into that 15 first, and then that 18 minus x that we named it. So we've got 15, 18 minus x, and then same thing, we're going to go around the other side. We get 10 first right here over x, cross multiply. So we're going to have 10 times 18 minus x equals 15x. So make sure you distribute. We get 180x, 180 minus 10x, sorry about that, is going to equal 15x. Add 10 to both sides, add 10x to both sides. We are left with 180 equals 25x. Divide both sides by 25. X is going to equal 7.2. Sorry, that dot wasn't clear enough. All right, last one in this section. So same kind of thing happening right here. We have this entire segment's going to be 35, and we know between these two parallel lines is x, but we don't know the distance between these two parallel lines on this transversal. So we're going to do the same thing. We're going to have the whole of 35, remove the part that we know in x, so this segment right here is going to be left as 35 minus x. So, example of the corollary to the side splitter theorem, we have 1, 2, 3 parallel lines. So we know that the segments are going to be proportional to each other. So we've got 20 over 8, and then we'll have the that we named 35 minus x over x, and we wrote that out here. Cross multiply again. 20 times x is going to give us 20x. And then we have 8 times the quantity of 35 minus x. Always remember to distribute. So we get 20x equals 280 minus 8x. Add 8x to both sides. We are left with 28x equals 280. If we divide both sides by 28, we're left with x equals 10. So some pretty easy numbers on that one. All right, final example. So the map on the right shows the walking path at a local park. The garden walkway is parallel to the walkway between the monument and the pond. So monument and pond, that's going to be parallel to the garden walkway, which is right here. So we've got two parallel lines in a triangle, so we're probably going to use the side splitter theorem. We need to figure out how long is the path from the pond to the playground. So we first got to figure out what x is. We can figure out the distance as a second part of the problem. But when we do side splitter theorem, we'll go down each side and find the proportional segment. So first things first, we get 60 on the top edge, and then 24. And then if we take the other side, we'll first see 2x plus 10, and then x. So we wrote 2x plus 10 over x. So we're going to cross multiply again. So we get 60x is equal to 24 times the quantity of 2x plus 10. We're going to have to distribute in this one. So we get 60x equals 48x plus 240. We're going to remove 48x from both sides. We are left with 12x equals 240. Divide by 12, divide by 12. We get x equals 20. So make sure you don't stop because this is not our final answer. Now we need to figure out the path from the pond to the playground. So we can just plug our x in over here. So we know from the pond to the garden is going to be 20. So we drop down to 20, and then from the garden to the playground is 2x plus 10. So 2 times 20 plus 10. So we're left with 40 plus 10 plus 20. We're going to have 70, and then it says in the image that we're working in yards, so don't forget your yard symbol. Again, if you have any questions, need any help with any of this, please join the live session or help session at the end of class, and make sure you join the live session to get those extra credit points at the end of the chapter.